Orbital Gardens, this is Mission Control. We are confirming acquisition of your signal. You are live in 5, 4, 3, 2...
Hello and welcome to episode 21 of Gardeners of the Galaxy, the podcast for all of the sentient beings in the universe who have a passion for plants. I am Emma the Space Gardener and I will be your host as we explore gardening on Earth and beyond. If you're tuning in expecting to hear an episode about Helen Sharman and her Project Juno mission, then I apologise. I got my dates wrong. That's going to be episode 22, available in a couple of weeks. In the meantime, stay tuned because I've got a great guest on the show today. Ben Greaves spent 2 weeks last year as an analogue astronaut on a simulated space mission, experiencing the highs and lows of isolation and a dehydrated diet, and he's going to be talking to us about an unusual plant experiment he carried out, as well as his exciting new Mars Cookbook project. Earlier this year, NASA shared pictures of astronaut Mike Hopkins transplanting the first seedling in the Veggie growing facility. He transferred healthy seedlings from plant pillows that had several into pillows where the seedlings failed to thrive. Transplanting seedlings wasn't on the original experiment plan, and the success of that process has opened up new avenues for gardening in space. During his time on the ISS, Mike took the lead on 4 veggie experiments, harvesting his last crops on the 13th of April. Veg03K and Veg03L tested a new space crop, Amara mustard, and a previously grown crop, extra dwarf pak choi. They were grown for 64 days, the longest leafy greens have grown on the station. The pak choi grew for so long that it began to flower. After consulting with NASA plant scientist Matt Romaine, Mike hand-pollinated the flowers with a paintbrush. Matt Romaine said that he wasn't at all surprised that Mike chose this route to make sure the plants were fully pollinated because he has always wanted to be very involved with the plant experiments. Matt also noted that the pollination procedure resulted in a high seed production rate. However, there wasn't time on the schedule to let those seeds mature. Mike also became a bit of a salad chef, marinating fresh leaves in an empty tortilla package. After adding soy sauce and garlic, he put the package into the food warmer for 20 to 30 minutes. Meanwhile, the rest of the crew has been enjoying the Amara mustard like a lettuce wrap, adding ingredients such as chicken, soy sauce and balsamic vinegar. Later this year, astronauts on the ISS will challenge their green thumbs to grow chilies in the advanced plant habitat, and an experiment to grow tomatoes in veggie is in the works for 2022. A few weeks ago, I asked my Facebook friends what questions they had about space plants, and I'm going to start answering those during the show. To start with, I have a question from Karen Summers who asked, how do plants breathe in space? Now, Karen put breathe in inverted commas because, strictly speaking, plants don't breathe, but they do need to exchange gases with their environment. A plant won't survive outside in the space environment, so let's talk about plants that are growing on the ISS, which has an atmosphere but where they have to contend with microgravity. On Earth, when they receive light to power photosynthesis, plants take in carbon dioxide from the atmosphere and release oxygen through pores on their leaves called stomata. The process also runs in reverse, with plants using their stored sugars as fuel and releasing carbon dioxide. Roots need to exchange gases with their environment as well. From the plant's perspective, none of that changes in space. The problem is that the way that gases and liquids behave changes in microgravity. There's no convection to move the air around, and water tends to cling to whatever's closest and can suffocate roots. So plants grown in space need fans to move the air around, as do the humans, and a lot of research focuses on how to give space plants enough water without drowning them. As an interesting aside, carbon dioxide levels are much higher on the International Space Station than on Earth. This can cause problems for the astronauts and give them headaches. You'd think it would be good news for the space plants, but that's not always the case. In 2017, Chinese cabbage Tokyo Bacana didn't grow as well in the veggie system as scientists expected. They blame the lacklustre performance on this variety's lack of tolerance to high CO2 levels. Hopefully that answers Karen's question. If you've got a question you'd like me to cover, or you've got any comments on this one, then let me know. Hi Ben, thanks for joining us today on Gardeners of the Galaxy. So, one of the things that struck me on your LinkedIn profile, you describe yourself as an aspiring extraterrestrial plant growth engineer, and I think that is like the best job title ever. So I'm really excited to have you on the show, and you'll hear about your recent experiences as an analogue astronaut. So that's really, really fascinating. And last year in November, you spent 2 weeks isolated in the HiSeas habitat in Hawaii. So can you tell us a little bit about what that was like?
Absolutely. Well, thank you so much for having me on the show, Emma. I'm such a huge fan. My time at HiSeas, and I know the space industry loves their acronyms, so I'll try to break it down for all the acronyms that I have in my little spiel here. But the Hawaii Space Exploration Analog and Simulation was an incredible dive into the importance of good habitats, good habitat design, and a cohesive crew for future space missions. I was privileged to have a really great crew run by Dr. Michaela Musilova. And while we did have our share of cloudy days, when we couldn't go outside for EVAs or extravehicular activities, the ones that we did were amazing. We did have some people on the crew that had experiments that were required to go outside to conduct them. We had someone that was working on communications. We had someone that brought along a lot of different robotics and weather monitoring equipment. Obviously, we had to go outside to set those up. And so right around halfway through our mission, we started getting this kind of spree of cloudy days. And so this is just one of the many factors that can affect a crew dynamic. Everyone was very positive, though. And I will say, because I was doing a plant-based experiment, I did not have to go outside, very much just had to start. And I will say that was one advantage of having a plant-based experiment, is that after you set them up to seed and you make sure they're all good to go, plants kind of go on autopilot. So I did have a little bit of time to help with some of the other crew members with their experiments. I also had the opportunity to do a nutrition study of all the different foods that we had. And I'm excited to talk about that a little bit later. But yeah, I think it was a really great experience to see, to really feel like what it would be like. And as someone, as you said, an aspiring plant growth engineer, that is something that, you know, I want to be acutely aware of what are the importance things here in the different habitats. We would also take two architecture surveys, one at the very beginning and one at the very end, regarding I would say our favorite and our least favorite aspects of the habitat.
Okay.
And this actually had me reflecting on how important the kitchen is. And this is something that you don't have to be an astronaut in order to understand is, you know, if you have a great kitchen, no matter how many ingredients, but, you know, if it's big, if you have all the pots and pans you need, you're going to have a little bit more fun time cooking. Yeah. And, you know, if you're isolated and your only food source is, you know, your crew cooking the food, you want to make sure that your chefs are happy. Yeah. And so that was one thing that, you know, while we did have, you know, varying levels of deliciousness with the ingredients, I will say that the fact that we had that HiSeas started, and this is something that you have to think of at the start. You can't design a better kitchen halfway through. I was really glad that they had such a great kitchen because that ended up being such an important aspect.
Yeah. Did you have anybody on your crew who was really a really keen cook?
Yes. So I would say we had a good balance, and that's another important thing is with any crew, you're going to have people that can cook, people that can't cook and they know it, and people that can't cook and they don't know it. And so you have to be able to handle all three of those. But we had our fair share, and some people, you know, they said, I'm not a good cook, so I'll do the dishes. And so, you know, you have that balance, and as long as you create that understanding at the beginning, that will be important. But we did spend Thanksgiving there, and so it was great that we did have some good chefs there because that was a great day for us.
Yeah, we'll talk a little bit more about that later because there was a visual aspect to Thanksgiving which really got me at the time. So we'll talk about that later. But you mentioned that you worked on a plant experiment, and this is Gardeners of the Galaxy. So let's talk about this. So I think you managed to provide a little bit of fresh food for the crew, but what you were really doing was testing some technology. So can you tell us a little bit about that?
Yeah, absolutely. So I got the opportunity to work with Dr. Tan Sui Ching and other researchers in the National University of Singapore SWE Lab, and their recently developed hydrogel. Now, hydrogel would take me longer than we have here to explain, but it takes many forms. Yeah. It can be very soft. This specific hydrogel that they have at the National University of Singapore is conductive, so it can be used to complete circuits. It can be clear, it can be opaque, it can be hard, it can be soft, it can be gooey. But the thing that I was investigating is its ability to passively absorb water.
Right.
So I first came across this material when I was designing a Martian greenhouse when I was doing an internship at the NASA Langley Research Center. And a colleague of mine had previously found the idea of a hydrogel and what they were capable of doing. And so through some of our literature review, we came across this particular one. And fortunately, they had published some numbers on, how much it's able to absorb. And I want to say the one that we're looking at could absorb about 4 times its mass in water.
Right.
So it was incredibly capable. And so after it would absorb the water, you would then heat it up to about 50 C. It wasn't super hot. And then it would desorb that water. And so they've done tests on even absorbing salt water and then desorbing the water. And they found that it's drinkable water. Yeah, and so it has a lot of applications. And specifically, the SWE lab had done a plant growth experiment before, but for 23 hours and 45 minutes of the day, the plant growth chamber was open to the atmosphere. Right. And then they would close it for 15 minutes, desorb the water to water their plants, and start again. So what I wanted to try to do was have it stay closed the entire time that we were there. And for context, the reason that I want to explore this is because, anytime that you can find a system that is lower in mass, lower in energy, lower in power, as well as lower in volume, it's a hydrogel, so you can kind of just customize how big you want it to be.
Yeah.
That's a huge advantage. So we're looking to essentially, could you replace mechanical dehumidifier systems with this material-based one? And so it was the first time that I was working with this material. So there was definitely a learning curve, and a learning curve that I had to overcome very quickly because my stint at HiSeas was only 14 days. But it was great. We had, some wins, we had some losses, but they definitely did a great job absorbing the water. I had a little bit of trouble. My heater ended up not performing as well as I wanted it to. So I wasn't able to perform the desorbing part. But I was able to look at both the hydrogel itself, as well as they sent me a hydrogel infused sponge that I would put in. And so that was a little bit easier to work with because it wasn't as sticky. But yes, so I had quite a riot with that. I was making a mess and doing science. So, as long as I got a little bit of good data there, and I was having a blast, and can't ask for much more than that. And I want to constantly thank the SWE lab for sending me that. They were absolutely incredible and helped me every step of the way.
Brilliant. I will put some links in the show notes to some of the stuff about SWE lab and the hydrogels for people who want to know a bit more. So, what did you grow in your hydrogel chamber?
Yeah, so I worked specifically with microgreens. This is something that NASA is exploring, as I'm sure that you've talked about on some previous shows. But they're basically small. They're seeds that are designed to grow small and very densely packed that allow people to deliver nutrients to astronauts very quickly. So they only take about 2 to 3 weeks to grow, and they're quite quick. And so I grew specifically a sunflower microgreen, which you expect sunflowers to be very tall,
Yeah.
stayed very short, and never really grew to flower. Just kind of their stems themselves is what we were looking for, as well as upland cress. And the upland cress ended up being a little spicy, and we were able to add a couple of them into our meals. It was mainly for the next crew because we were just about to leave as they were really starting to mature. So there is a little bit of a camaraderie between plant scientists with every HiSeas crew that we had some great plants already started from the previous crew that we got to eat. And then, we tried a couple, but most of it was for the next crew. And so, there were, they grew quite well. I was very impressed. And they added a little bit of a zing to some of our meals towards the end of the mission.
Excellent. So, did the hydrogel mean that you didn't have to water them, that they were basically going to take care of themselves the whole time?
So the benefit of microgreens is that, you really just water them once. But yes, that would be kind of the whole idea moving forward, is that you could absorb it from the air, hypothetically, and we'll say in microgravity. As long as you have a fan that's circulating the air well, you could absorb that water from the air and then desorb it in another chamber, and then perhaps, pump it back in through if we still have plant pillows, you could pump it back into there. Any sort of hydroponic system, you could pump it through. It was mainly a way of how can we collect that water and passively reuse it and keep it within the system while also maintaining the proper humidity that we want in the air of the chamber.
Okay, so other than the veggies that you grew and you managed to eat, all of the other food that you had in HiSeas was dehydrated. And for Thanksgiving dinner, and this was hilarious, you had rehydrated chicken, which didn't look that great, but then somebody made a loaf in the shape of a turkey, so you had something to carve, and I just thought that was brilliant. What was it like living like that for 2 weeks?
Yeah, absolutely. And I will say we definitely had our share of jokes with "Where's the wishbone" in our bread turkey. That was all thanks to our crew journalist, Cassandra Kloss. She was very creative and I would say very patient that day with handling the bread. We tried to recreate the famous Thanksgiving painting by Norman Rockwell, I want to say.
Okay.
And so it was we just had a total blast that day. And so let's see. So the food itself, I did get to do a nutrition study for, where I literally just took every single product that we had off the shelf, and put it in a catalog of all these foods just to see kind of what were some of the micronutrients or macronutrients even that we might be missing.
Yeah.
And so not surprisingly, most of it was the vitamin Bs that you typically get from fresh fruits and vegetables. So that was an interesting study, and it just goes to show that we're going to need this plant growth in space. In terms of the meals themselves, I would say dinner was ended to repeat itself. You really started to see that lack of diversity in the dinner. But I will say, at least in my household, breakfast is usually always the same, and for some reason, we're okay with that. We do have some variety, but it is odd. We will have cereal every day and be okay with that. But, if we had a chicken burrito every night, we would probably get bored of it. So it is interesting, these social constraints that we put on ourselves. And that showed itself with some of the repeats for dinner. And let's see, the other thing that I noticed is the importance of snacks. So we want diverse crews, and along with that is going to come diverse body mass and diverse metabolisms. Yeah. And so while we did all sit down and eat together, sometimes people would want to eat more than others. And so, we really didn't get to establish in the 14 days, I tend to eat a little bit more. Is that okay with you all if I kind of maybe eat a little bit more of our shared dinner? And so since we weren't able to do that, but you can't control hunger, we ended up having a lot of people snacking.
Yeah.
And so the banana chips were the first victims of that. And I will say I was quite surprised when I saw how much fat was in those, because those are just dripping in oil. And I was like, oh, maybe you guys don't want to look at this nutrition label after we ate that whole tin. But yeah, so Thanksgiving dinner was great. The meat was actually pretty good. I'm typically not too picky of an eater. So, I know there might have been some other of my crewmates that were maybe a little bit more sensitive to the dehydrated foods. But, I think, there would definitely be some meals in which we're like, this might not turn out well. You guys are going to have to just be patient with me on this one. But they all ended up being okay. We also had our fair share of seasonings that might have helped. Yeah. Put enough garlic powder on anything that it'll taste okay. So, but yeah, so it was a really great whole mission. I got actually sponsored to go out there from the Secure World Foundation. So that was such a great opportunity. And yeah, it's been, we now have a full HiSeas alumni chat, and so it's really great to connect with other crews and see what their experiences were.
Okay, so since you landed back on Earth, you've started a new project called Mars Cookbook. So what's that about?
Yeah, absolutely. So this was initially started from a greenhouse design, Gaia, that I designed along with Jay Bunches, who's down in Antarctica right now, I heard you gave a shout out for. She's one of my good friends. And so after designing this greenhouse, Jess and I and the whole crew really, or the whole team, I'm saying crew now, the whole team really, we were a collection of engineers and plant scientists, and, growing the food is only half the battle. You have to cook it and prepare it. And, we weren't really culinary experts. And so we reached out to this group, Hank and Bean, in Los Angeles. They're two incredible chefs. And we basically spoke with them of, we've designed this greenhouse to completely supplant the diet of a crew of 4 on Mars. And, we know how to grow it and harvest it, but we really don't know what's the next step. And we want to create this dietary diversity, and we want to, have fun with this and make it an artistic work. Can you work with us? And they had also done a Mars night in which they kind of designed a meal that was about food that was just grown on Mars. And so they were clearly interested in the topic in general. And they were completely supportive. They were totally on board. And, the rest is history. We initially looked into the MIT Interplanetary Cookbook Challenge.
Yeah.
We submitted that to. And, we weren't, that wasn't enough. We wanted to keep going. And so, MarsCookbook.com. We're also Mars Cookbook on Twitter and Instagram. But we're basically a collection of plant scientists, chefs, engineers, artists, that are just interested in food and agriculture in general. And, while we do have a specific focus on space exploration, we know that food is connected to almost every aspect of our life. It's culture. It is an aspect with climate change. It's nutrition. It's health. The energy sector is also involved. It's politics. It's war. It's peace. And so, as I'm sure that you found with Gardeners of the Galaxy, there's really no shortage of topics that you can talk about when it comes to food. And so that's what we're going to be exploring. The foundation of everything will be this cookbook in which we come up with these recipes, and that would be grown strictly with plants on Mars. So it's also regarding sustainability and a sustainable diet. But, we're also going to talk about space exploration in general, and, how can we move forward sustainably and bringing space for everyone and making sure that everyone has the opportunity to be involved in the space industry. And I think it's going to be a conversation. We also want to do a podcast, but it's going to be a cookbook, conversations. We want to reach out. We want to reach out to you too. I think that you've learned so much along the way of all this stuff. And so we love your take on things like this. And so, sometimes we're going to talk about the culinary side of things. Sometimes we're going to talk about the engineering side of things. Sometimes we're going to talk about our favorite plants.
Yeah.
And so, check it out. And I'm really excited for kind of what's taking off with that.
I'm really excited to see what comes out of that. So I'm going to be keeping my eyes on it. So that's fabulous. So you were talking that, you mentioned that you might be talking about your favorite plants. So if you had the opportunity in the future to join a settlement on the moon, or maybe on Mars, or possibly Venus, wherever, if you could take one plant with you, all your food needs are met, but if you could take one plant with you to be your personal plant, what would you choose and why?
Absolutely. And I'm glad you mentioned Venus, because I'm a proud Venusian. I'm very excited for Venus floating cities. I think I would go with blueberries or caneberries, like blackberries and raspberries. They have those antioxidants that would be helpful for any sort of space radiation. I've also seen a recent article that they're looking to grow some of these bush plants in hydroponics. With pretty much every space-faring plant, it will have to be probably done hydroponically. Yeah. So that is an exciting development for that. So it's always nice to have that little sugary fruit. I think it's going to be really important. They call strawberry the celebration fruit. So I think blueberry, blackberry, and raspberries could do that too.
Yeah, I think, because strawberries would be kind of easy, but the perennial, the more sort of the bigger bushy things we haven't seen those in hydroponics yet. But tough. Blueberry muffins would be great.
Absolutely. Oh my gosh.
They're a popular thing on the International Space Station. Be able to make your own with Venusian blueberries.
That's right.
You've got an export crop there, haven't you? Venusian blueberries sent all the way back to Earth. People pay well for those. Yeah.
I think so.
So we've
I
got a
think you're
business
onto
venture
something
going
there.
there as well, yeah.
Absolutely,
Let's
absolutely.
patent that now. Yeah. Okay, so that's absolutely fascinating. So nobody said blueberries before, and I really love the way that everybody has their own take on this, whether they want something that they're going to eat or whether it's going to be, just a house plant that they're going to love and take care of, and some of them have a history and some
Yeah.
of them don't, and that's just really fabulous because I love looking at the way that different cultures approach this problem, and they have different things that they want, and I think that's one of the things that's going to come out of the Mars Cookbook project is that sort of diversity is essential, I think, to space exploration. So that's great.
Absolutely.
So it's been really great talking to you, Ben, and I'm going to be keeping my eye on the Mars Cookbook project. So I'm sure we'll be coming back to that in future episodes. Thank you so much for coming on the show. It's been great.
Thanks so much for having me. This has been excellent.
Excellent. Thank you. Ben mentioned Jess Bunchek, the NASA plant scientist currently growing plants in Antarctica with the Eden ISS. On Tuesday the 4th of May, NASA is hosting a webinar about Antarctic plant research with Jess and NASA's Dr. Ray Wheeler, alongside Dr. Daniel Schubert from the German Aerospace Centre and Dr. Tim Heitland from the Alfred Wegener Institute. I'll put a link to more details in the show notes for you. I'd love to hear your comments on the show. You can comment on the Podbean homepage, on my website, on Twitter, Facebook or Instagram, or email me, and the address for that is earth@spacebotany.uk. That's it for this episode. Ben reminded me to get the show onto Spotify, so it's available now for Spotify users. As usual, you'll find the show notes on my website, theunconventionalgardener.com, which is also home to a virtual tip jar for those of you who would like to support the show. If you want to join the fan club, you can sign up via patreon.com/gardeners of the galaxy to access extended episodes and bonus content. I'll be back in a couple of weeks with episode 22. Thanks for listening. Goodbye.
Orbital Gardens is mission control, confirming termination of your signal. I've thought about it, and the plant I would take to Mars would be an oak tree, because I want to breed squirrels on Mars. Mission control out.